You got them?
Yeah.
Okay. Yeah. So move them closer. The further away they are, the more likely you are to drop them before you actually get them in the place where you want to put them. Take it out. Sort of. With that time, just let the solution get off as much as it can. Larger one on the bottom, just because it makes them easier to stack. So whichever gel it is you have, larger on the bottom. Yeah. Make it so that they're facing into each other, so that the side which has the sort of curve, which would be the side that was in the bottom of the beaker or dish that you've moulded them in, is on the outside, is the one that's facing the electrodes on either side. Do your best to remove air bubbles. It's difficult to get them all out, especially if the surface texture of the particular gel that you're using isn't neat, but just try your best to get them out. Move that out of the way, and put in the screws, secure it, the springs that go on there, and just down, and then screw it into place. It should be screwed down just enough so that the each contact is covered entirely by the gel as it pushes itself into the gel. Which you might have to sort of have a look inside, just sort of make sure. If you can't tell, it sometimes helps to sort of like just poke the surface of the gel, just to sort of check where the actual surface is, because it's transparent. It can be difficult to see where it actually touches the electrode. Apart from that, make sure that both sides are at the same height, and you can always adjust them slightly so that it levels off into sort of, just make it so that the top set of electrodes is sitting level with the bottom set. It's mostly just sort of try and get it as neat as you can, because it helps with it, but also it shouldn't affect it too much if it's only off slightly. As long as it's roughly similar. Then turn on the power supply and run the program that is serial plot 2. Also plug in the actual rig, that is the USB for the drum rig. Yeah, so run that one. This will just bring up a graph that shows the current that's being measured. At default it should be basically around 0, that's just the noise coming in from it. Then on the power supply, turn on the 2 volt one, which is the blue and yellow on this, but it's the 2 volt. And then you'll see on here that they will immediately rise to about 1 milliamp amount. That means that each of the positions is being sensed correctly. If any of them were disconnected, they wouldn't increase, they would stay at 0. Turn it off and turn it on again just to make sure that there is a proper connection there. Then just leave that going until the entire thing is across. Up here is the average measurement for this entire region. Once that's across, take the average measurement for each one, make a note of it, and then those will be the base measurements that are used to normalise the data as it comes in. So just wait for a few seconds until that gets to the end. So in this case, so write down 83, 94, they will probably change as you're writing them. Just write them in as you see them, and then just before you close it, make a note of it. So yeah, 2, 3, 6, 4, close it, shut that off between the ears. So 3, 6, 4. So those are the measured ones of that. So make a note of when you've finished doing it, having it in the solution. Then go into the one labelled Pong and then scroll down to here. These are the default values, and put in the ones that you measured into there. So 83 for black, 96 for brown, 94 for red. And save it. Then go into threaded Pong, which is the main program that actually runs the entire thing. Press play, then start both power supplies. Let it open up, move them around so you can see them. It will record the screens so we'll be able to see both of them. Then for the initial running of the gel, keep track of where the ball is. Make sure that when it goes into each of these regions that there is a current measurement on here. If there isn't, that means that the connection has been lost between that position in the electrode arrangement and the power supply, so you can then check your connections in those 2 points. Also check that for whenever it reaches one of these 3 locations, you can see a spike in the current measurement in that corresponding location. And so far we've seen that the black has spiked at the right location, red is spiking at the right location, and brown is spiking at the right location. So we know that the it is measuring properly and it's applying it properly in both situations. Sometimes when you're running it, the ball will freeze, but that's just because it's waiting on communication between the Arduino that's running the system, and it won't actually prevent it from going, so everything freezes at the same time. So it doesn't actually stop any data from being recorded. Before you run this program, make sure that you've got enough space on the computer to record it. It records the video of the screen whenever it records it. So, and if you're running it for an hour, which is how long I leave it to run for generally, that can be a video file that up to 6 gigabytes. So make sure you have probably at least 10 gigabytes of space on whichever computer you're running on for it to actually be stored in. Yeah, so yeah, generally leave that going for about an hour. The learning seems to happen during the first 1000 to 2000 seconds. The seconds that are passed is shown up here. 1 hour is 4000 seconds, so that's generally at the time that I turn it off. In this program, something that I've noticed is that this isn't actually accurate to the right time. That is not milliseconds, but I haven't been able to change it, and all recorded data that I have so far has that video recording of the screen. So I think it's easier to put a note in the data that says, ignore that. Yeah, so the gel tends to break down after a while because of the gel running. In fact, you might be able to see it currently. The gel running, you'll see that the around the electrodes on the simulation side, they'll start sort of getting green and brown just as it reacts with the gel. It's a good way to make sure that the gel is actually reacting, or the electrodes applying a simulation, that the gel will start to get darker and darker, which you can actually see if I put the in here. It will sort of turn that kind of horrible brown green colour as it just sort of, basically as the electrodes start to oxidize with the gel, with the electrolysis process going on as well, because there is salt solution. And yeah, you'll see that they're actually reacting, so you know they're reacting. And after that happens for a long time, generally a hole will form in the centre of the gel because the ball goes through the centre more often than anywhere else. At that point, because there's a hole now in the middle of the gel, it won't be able to learn anymore and it won't be able to run anymore, so you might as well at that point stop the process, even if it hasn't been an hour yet, because you're not going to learn anything further from that. At that point, you just stop the game by pressing the X on the graphing window, wait for the ball to stop moving, then press the stop button up there, and then just turn off both power supplies. Check in the file, which is the folder called data, which is in the same file location as the programs are. Check that has the data in that you recorded. Then disconnect the connections from it, unscrew it, take the gel, put that in just some kind of container just to be thrown out later. Remove all the electrodes, put those in another container, again just to be thrown out later. clean off the surface just with some rinse it off some water, and then just wipe off any residual gel that's left in there, or try and remove as much of the sort of rust staining. There'll still be some staining just because it's plastic and it gets stained by rust. And then once it's all cleaned off, you're ready to do the next one. Yeah.